start this. I realized I should do my my typical YouTube intro. Hey guys, so today I'm going to teach you about present value of an annuity and installment payments. Really quick, easy. No, takes 2 hours. We'll see. Probably not, but we'll see. Okay, I guess we should do a smidge of review. Let's see if these are separated. All right. Can I build on the review from last day? Sneaky. I'll do this. Mostly because we're going to build on this compound interest formula today. So if we have simple interest, we know the formula. We kind of leave that in the dust now. And then if we have an amount that is being deposited, right, or potentially borrowed, a principal amount, and we let it sit there with compound interest, then we get some accumulated amount, or we call it a future value at the end of some time t. Is that a question hand or no? Just a stretch. That's allowed. It's allowed. I realized I also should bring in these definitions so I don't need to write them out again. And maybe these too. Review of the review. Wow. That is luxurious. Just keep adjusting these things. I know everyone had me worried. Yeah, skip it.
No.
Hurry up. If we have an annuity, then the accumulated amount we found by what formula? M times something, something, something. Wow, jot that down. This one I don't have memorized yet. M, yes, bracket 1 plus R over N to the N to the T minus 1 end bracket divided by R over N. All of these guys we know and love, right? We know what A is, we know what R is, we know what N is, we know what T is, and the only new player is M. So I'm going to add that to our list. M is the amount of each periodic payment. And so it's the amount of each periodic payment. We are still working under the assumption, and we will always work under the assumption that our N is also the number of compoundings per year, but also the number of payments per year. And so let's add that. Wow, I really did not anticipate, well, how much room I needed. So N is the number of compoundings per year, and the number of payments per year. There is a way to adjust your interest rate so that it matches. So if they are not the same, then mathematically we can adjust the interest rate to match the payment frequency. But usually we end up just using a calculator for that anyways, and calculator functions. And so we don't need to worry about that. And it only changes the formulas slightly. Okay. So that's the N is the number of compoundings per year, but also the number of payments per year. So we've built this out, all our skills, right? Started with simple interest, and then we leveled up to compound interest. And then we introduced, okay, well, what if I have regular payments and then I want to have some accumulated amount at the end, right? This assumes that we start from 0, right? And then the accumulated amount. And today we're gonna build out on it a little bit further. So oftentimes when we're making regular payments, usually we're not building towards some accumulated amount, although that would be nice, right? Often we're making regular payments to pay off a loan, right? So to pay off some principal amount that we borrowed. Yeah? And so that's what we're building towards today. And so the present value of an annuity is the amount of money we would need now in order to be able to make the payments in the annuity in the future. There's a typo here. In other words, the present value is the value now of a future stream of payments, or usually, or more kind of commonly, it's the amount of money that you've borrowed, and then you have to pay it off, right, in some set amount of time. Or commonly a loan amount we need to pay off. And so this present value is going to be a principal amount. And so we all understand if I borrow $100 at an interest rate of 4% at the end of a year, right, let's say, then I'm gonna have to pay back not just the $100, but also the interest, right? And so kind of a bummer, but same thing, you buy a car, you borrow money, and you make your payments, right? But those payment amounts are not going to be the same as you just took your loan amount and divided it by however many payments. You have to pay interest on each of those payments. So that's what we're working on today. Okay. If you're paying off a loan, what would your accumulated amount be? Now we're kind of working backwards. So if you're chipping away at a loan, right, you've borrowed money and you're chipping away at it, at the end of the term, right, at the end of time t, the amount should be 0, right, if it's paid off, right? And so in a loan scenario, so for loans, we know the accumulated amount should be 0. Right, paid off at the end of the term. So it doesn't really come into play, but we also want to introduce this idea that, okay, if I just borrowed a lump sum of money and I'm paying it off, right, then that should have the same value as if I just had that lump of money already and I put it into an account and let it grow, right? And so that's one assumption that we're making here. We're going to be making. But let's let it happen naturally, organically, if you will. I'll add a page here. No. I don't like having the question on the next page. Aesthetics, you know. I've moved it back. How about this? Copy, crop top, paste, crop top. That's problem solving. So as an example, just to build this up, okay? Suppose Carlos owns a small business and employs an assistant manager to help him run the business. I think we all assume that that's what an assistant manager should do, but okay. Assume it's January 1st now. Carlos plans to pay his assistant manager a $1,000 bonus at the end of this year and another $1,000 bonus at the end of the following year. Carlos's business had good profits this year, so he wants to put the money for his assistant's future bonuses into a savings account now. Right? He's flush. So he's going to put it into an account and be prepared to pay those amounts. Okay. Then the money he puts in now will earn interest at a rate of 4% per year, compounded annually, while in the savings account. Haha, I figured out a use for this space. I know, that's half my job, I think. Figuring out how to space things on a page. No. But here we are. We can map this out. January 1st. Okay. Let's say 2025. Yeah. He's feeling flush with cash, and at the end of this year, he wants to be prepared to hand over $1,000. So the timeline for this a whole year has passed, and this is, or essentially a whole year. December 31st, 2025, right? So from January 1st to December 31st, and then also the following year, December 31st, 2026. He's also going to be prepared no boosts, huh? No inflation, nothing. Still $1,000. All right, all right. So what he wants is to figure out, okay, what amount do I need to deposit today on January 1st in order to have it grow at 4% compounded annually, so that a year from now I can take out $1,000 and then the remainder will grow to another $1,000 in another year. And so how can we find what this looks like? What we can do is we can kind of pull these amounts back, right? That $1,000 each time is some accumulated amount, right? So it's accumulated to 1,000, and then the remainder is accumulated to 1,000, right? And so each of these, you can kind of, wait. pull them back to January 1st. And these can be some principal amounts, P1, P2, let's call them. Because this, let's say, is accumulated amount 1 and accumulated amount 2. They happen to be the same, right? And I want to pull them back, and T for this one is 1, and T for the other one is 2 years, right? They're in there for different lengths of time. And interest is compounded annually, so N is 1 for both of those. N is 1 and the rate is 0.04. Okay. How much money should Carlos put into the savings account now so that he will be able to withdraw $1,000 1 year from now and another $1,000 2 years from now? And so this, the sum of these is the total. How much money should be put into the savings account now, right? P1 is going to need to be slightly larger than P2, right? Because P2, whatever it is, sits for longer, but has to grow to the same amount, right? So it has longer to grow to $1,000. But what we can do is we can say, okay, well, I'm making payments, but those are the accumulated amounts in these, in this scenario, yeah, because we're just kind of building up the reasoning. But what are we going to do? Compound interest, we have A is P times 1 plus R over N to the power of N times T. That's in general. And we can work with the first principal amount, P1, and then we can work with the second principal amount, P2, solving for P in both scenarios, right? The A is going to stay the same, right? We force the A to be $1,000 each time. And so A1 is P1 times 1 plus R over N to the N times T. Let me just make sure I have the right, formula. That would be such a bummer. 1 plus 0.04 over N is 1, that's nice. 1 times 1, right? Oh, I guess that's kind of cute. P1 sat there for 1 year and P2 sat there for 2 years. Ah, that was a fluke. That wasn't on purpose. All right. 1.04 to the power of 1. It's 1.04. P1 then is 1,000 divided by 1.04. P1 is 961.5384615. In money, 2 decimal places, 961.54. I'm going to do the same thing, but for the second amount. And so A2 is P2 times 1 plus R over N to the N to the T, or N times T rather. The accumulated amount, we're forcing it to be 1,000 again. And solving for P2, 1 plus 0.04 over 1 to the power of 2 this time. So 1.04 to the power of 2 means that P2 is going to be 1,000 divided by 1.0816. $924.556213, or in monies, $924.56. Which, as we suspected, this 924.56 has an additional year to grow to $1,000, right? So we need less to start off with, right? Whereas this 961 only has 1 year to grow to $1,000, and so it needs to be a little bit more. And so the total Carlos would need P1 plus P2, which is 961.54 plus 924.56. I did hit a button, so this might be off, but I get $1,886.10, right? As opposed to actually paying $1,000 twice, right? Which would be $2,000. So saves him a little bit of money by depositing it while he's flush with cash. Feels like a sinking fund, right? But what were we doing with a sinking fund? A sinking fund, we needed some end goal, right? We needed some amount at the end to buy equipment or whatever, right? And so then we were making payments and we were pulling them forward, right? We were depositing and letting it grow, depositing, letting it grow until we had some final amount. Okay. Whereas now we're trying to figure out, okay, what principal amount is going to be equivalent to these payments, right? These periodic payments. Then what are we saying? On January 1st, 2027, he's got zero monies left, right? Because they were all allocated to the $1,000, right? He'd have to start over. That's okay. That's okay, she says. Carlos can do it. So similar to a sinking fund, but it's kind of in reverse. This is similar to a sinking fund. But in a sinking fund, right, from last day, we make payments, right? We make periodic payments and let them accumulate, right, until we have some final amount. So we make periodic payments and let the accumulated amount I don't know how to spell accumulated. Just throw some bumps in there. Accumulated amount. I think it's just 1M. Accumulated. Accumulated. Have you guys ever thought about when you say, I edited it? I edited it. I edited it. Yeah. Asterisks. Wow. I can see that one. My deep, dark secret is I think I say vacuum wrong. No, just vacuum. I have a hard time saying it in a sentence. Like, oh, and then I'll go and vacuum the floor. I always pause before it. Okay, vacuum. That's
crazy. Crazy.
The whole world knows now.
Be sure to like and subscribe. No, I don't care. Aw. Nice. I posted so many videos. I should be famous by now, but they're all so boring. I think there's like an opposite of famous. That's me. Yeah, I'm surprised they don't contact me and they're like, you can't just use this for storage. You have to actually get some traction. Yeah. Yeah, and they're not our usual complaints. It's just so boring. All right. And let the accumulated amount grow to a specified amount, right? Whereas here, we're making a deposit in order to sustain future payments. Whereas in this case, we make a principal deposit. Right? That's going to be called our present value. I think referring to the name of the section, it's called present value of an annuity and installment payment. And so we make a principal deposit, which is going to be kind of referred to as our present value. And let it grow. I'll say which will grow to sustain periodic payments. To sustain periodic payments. For a set amount of payments. Okay. So the thing about this present value, right, is it essentially needs to be worth the same amount at the end of the term as if it was a sinking fund with those payments. Okay? And so they're kind of linked. And let's do this kind of classic example. What do you choose? It's impossible to know. Well, no, it's not actually. We're going to know how to figure out which one we would choose. So suppose you've won a lottery that pays $1,000 per month for the next 20 years. All right. What's the set for life one? I think it's 25 years, but is it $1,000 per day? I don't know. It's set for life. It has to be really good. $1,000 a month, that's not set for life.
I was gonna say,
Yeah,
that's monthly.
that's like, I don't know. But anyways, someone can look up what the set for life lottery is. That's not important, but we can work with that instead. So this particular lottery pays $1,000 per month for the next 20 years. But you prefer to have the entire amount now, right? You want, okay, you want this this theoretical $1,000 per month for the next 20 years. That's worth something today, right? Every week. That's good. Yeah. I mean, you could have some fun with that, I think. Especially you could work for fun. And that's set for life, I think. $1,000 a month? Pretty good.
Vegas.
Put it all on red. Luckily, we will talk about probabilities in this course as well. So we'll kind of revisit the trip to Vegas maybe later.
Yes, you help me cheat. I'm taking this course.
So, how much will you accept? If the interest rate that you can get is a whopping 8%, that is an amazing interest rate, I'll tell you that much. But how much would you accept today, right? And then the theory is, okay, if you accept a lump sum today, then you should be able to have that sustain at least $1,000 per month for 20 years, right? And so I find it helpful to draw out the diagram. If you don't, that's okay. But let's just kind of plot it out and see what it looks like. So today, you won the lottery and you're so happy. And this represents 20 years. Every month for 20 years, which is how many? 20 times 12 is 240 months. Here we're at 1 month, 2 months, I cheat because I don't want to draw all those out. That sounds terrible. But I do check back in here at 239 months. And they all behave the same. So at each month, I'm going to get $1,000 per month. We did talk about annuities due, which is when the payments are at the beginning of the month, but we'll kind of shake that and we'll just focus on regular or ordinary annuities, they're called, where payments are at the end of the month. And so you win the lottery today and they say, wait for your check. Here it is, $1,000 or deposit or whatever. Hopefully not checks. It's terrible. $1,000, $1,000, $1,000, and the last $1,000. You could, in theory, do what? You could find P1, P2, P3 or 239, and the principal value of P240. Got a page break there that I'm dealing with. How about this? No, it's not on the line. Oh, well, whatever. This is how much it's worth today, right? This is the value of this prize today. And so you would accept more than this, but you wouldn't accept less than this. right? And so this is the value of the prize today. Right. No, it's just as long as you kind of have an idea that usually I do the first two and the last two just to kind of illustrate, but no, it doesn't matter. Well, so there's a bunch that I'm not showing here, and they all need to be done as well. But we have a formula for that. Don't worry. But we could do this, right? We have those skills already, but we're kind of leveling up our skills. In fact, there's no new formula. We just combine two formulas. Wow. Okay. So. That's fair. Thinking about winning the lottery. Wow. Like, where in Mexico are we going? Doesn't matter. I'm just curious. Yeah. There's a glitch in the matrix. We don't have the compounding frequency, but we also only know how to have the same compounding frequency as the payment frequency, and the payment frequency is monthly, so we're going to have to just assume that it's compounded monthly. N is 12. Oh, thanks, guys. Okay. So here's where it gets, well, I'll ask you this. Do you want me to kind of talk you through it first and then give you the formula, or give you the formula and then talk about why it's true? Probably give you the formula first and then talk about why it's true. Convince you. When I worked at a market research firm, I had a coworker who's Chinese, and so I guess there's a proverb that says, if you can't convince them, confuse them. And so we used to say that a lot. You can't convince them, confuse them. So I guess hopefully that's not what I'm doing, but the formula is going to look like this. P times 1 plus r over n to the n times t. That looks familiar. That looks like just a compound interest formula. Okay. This is A for compound interest. Here's where it gets a little hokey. We're going to force this to be the same as A for all these payments. Okay. Which looks like what? M times, now I've lost it again. Good thing I've got it. 1 plus r over n to the n times t minus 1 over r over n. This is A for an annuity, right? We have these regular payments M, and they're going to be worth something at the end. So this is basically treating it as a sinking fund. Yeah. Right. So briefly, to compare these two and to make sure that they're equivalent, right? Then we treat these payments, instead of pulling them backwards, the trick is to pull them forwards and say, okay, after 20 years, then how much would it be worth, right? Because this total value of the prize should be worth the same as that accumulated amount from the sinking fund 20 years from now. And that way they're equivalent. Okay. Sold. No, I'll write around it a little bit more. Okay. So if we have today and 240 months, and we're making payments 1 month, 2 months, blah, 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 239. What we're saying then is that, what color can I use? Green. These payments are going to be worth some accumulated amount, right? And so here, A from the payments after 20 years, right? For the length of the term. Ooh, that's what I'll do. I'll change this color to green so that they can match. Matchy, matchy. How about that? Okay. But in order to be equivalent, right, there's some lump sum today that I can invest for 20 years. And if these payments and this P are meant to kind of represent the same amount, then it should grow to some amount just from compound interest. For 20 years. And so if these two are set equal to each other, right? And maybe I'll change this equal sign to match, right? I force these two things to be equal. And then, right, that P that we can solve for here, right, is equivalent to these M payment amounts for 20 years, right? Or 240 months. Right? So that's the theory. Okay. And from this setup, okay, we'll either be solving for P, right? What amount would I need to get now, right, to compensate me for not getting $1,000 per month for 240 months, right? That's worth something. Okay. Because then I could take it to the bank and I could invest it 4% or more, right? If you have a better interest rate than 4%, right, then that would be worthwhile taking this and letting it grow a little bit bigger. Anyways, but the other thing that we could solve for is, okay, well, what payments would I need, right? And usually P is the amount that I've borrowed, and M is the amount that I need to pay each month or each week or whatever to pay it off, right, in some set amount of time. Okay. And so these are the two things that we'll be solving for, okay? P and M. Okay. All the other guys here are pretty similar, right? Besides P and M, we've got R over N, R over N, R over N, N times T, N times T, no other players, right? So they're kind of boring, right? The only interesting thing is maybe if you adjusted your payment amount to solve for T, a little bit trickier, but you could do that, right? What if I increase my payments by $100 each month, for example? I can't remember if we do it in the next section or not. We level up once more in the next section. But then there's no more levels for us. Pretty good. Okay, fine, I'll tell you. What if you have some amount and you let it grow and then you get payments from it later? Then there's kind of a compound interest and then followed by an annuity, trust funds, etc. I've said too much. Hey, we didn't solve this problem. You won't get away that easy. So what amount, how much would you accept today, right, as a lump sum? So we've got our R, we've got our N, T is 20. And that's really all we need. Oh, and the M is 1,000. And so we want to solve for P. I used to do it all nice where I just highlighted what we were looking for and then wrote down all the things that we were given. And I'll do that for the next one. I got carried away. All right, so we can figure out this chunk for P, or except for P, right? We can find 1 plus R over N to the power of N to the T, that's, or N times T, that's just gonna be a number, right? And we have all of these components. So nothing to it but to do it. One plus R over N to the N times T minus 1. Once you have this, right, that happens here again, right? And you're allowed to recycle that, right? If you've solved for it once, you can just store it in your calculator, maybe. Might be a nice one. Divided by R over N. Solving for P. One plus 0.04 divided by 12, right? We forced N to be 12 because we're getting monthly payments and they have to be the same. 12 times 20, we already decided, is 240. M is 1,000 times 1 plus 0.04 divided by 12 to the power of 12 times 20 minus 1 divided by 0.04 divided by 12. So noisy downstairs, I think it is. I always forget there's an upstairs up here. They're pretty quiet though. Geography and stuff. 12 times 20 is 240, and I hope 0.04 divided by 12 is bad. Ugh. Better store it. I was hoping. But if I do 1 plus 0.04 divided by 12 to the power of 240, right, that's going to be a nice number to store. Okay, because it comes back into play here, right? And so notice that this is the same as this big chunk. To the power of 240. And I get P times 2.222582087, which I'm gonna store in A. No? 0.04. Oh, wait, was it?
That's what I was wondering.
Can I erase your minds? Or do I have to do it in red? That's when I punish myself. Nice. You guys are sweet. It's still a bad number though. Ah. Okay, this one I'll just delete and start fresh. Nice. Thank you. +1 to the power of 240. There we are. P times 4.926802771. That I'm gonna store in A. Any objections? No. Nice. And that's gonna be equal to 1,000 times, and I'm just gonna write store A because I'm lazy. -1. Over 0.04 divided by 12, mostly because I don't want to write out 0.66666 or whatever it is, 0.00. So I'm going to simplify, right? Take whatever I stored in A and -1 first. -1, and then, which obviously puts me at 3.92, blah, 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 times 1,000. Times 1,000. And then I'm gonna divide by 0.04 divided by 12. As long as you use brackets, you should be safe, right? If you throw some brackets around here, you can put them right into your calculator. And that way you'll ensure that you're keeping all your decimal places. Alternatively, you could store 0.04 divided by 12 in your calculator. Oh my gosh. I sensed some unease over this, and I should have caught it. Good thing I haven't done it yet in my calculator. I'm hung up on 4% for some reason. All right. Such an amazing rate. Okay, now I'm ready to divide. Now I really need you to check my work. 0.08 divided by 12 in brackets. I get 589,020.4156. I'm gonna keep that on my screen because it does presumably keep going. It's just that the screen doesn't show me more than some number of decimal places, right? Or some number of digits. And so I'm gonna keep it on my screen and then divide by store A. And so here, this is P times whatever is stored in A. So then P is, and did you guys get that? The 589,020, or did I do it wrong? Phew. Divided by store A. 1,19554.2917. In monies, $119,554.29. That's gonna be the minimum that you would accept, right? Because if you walk that to the bank and you deposit it at 8% and you let it sit there for 20 years, then it will be worth the same as if you got all those payments, right? And so that's the idea. Yeah. Even though $1,000 for 240 months, that does make $240,000. But some of those you have to wait 200 months for, right? Or one of those. So you have to wait a month, wait a month, wait a month. And every month that you wait, you could have been making interest on it, right? So what was the question? Can you repeat the question? How much will you accept? You would accept at least. You got it. Well, that's the thing, they're equivalent. But they might come back to you and say, oh, well, we'll give you 100,000 now, if you want it right now. And usually that's the case, right? They offer you some lump sum now. And I can't remember which scenario it is, but sometimes it'll be a little bit less than if you took the payments, and sometimes the payments are more. So that's why you want to be able to play it out. So you would accept $119,554.29 or more. Can I do a smirk emoji? It's pretty good. Can I maybe like a little bit more of a crook there?
What's the concern now?
I'll stick to my old school emojis. Or more today. Nice. Okay. Any questions about that one?
No. Test, you get, like lost so much. Are you able to do that as in the right direction?
Yeah.
Like if it's bad,
Yeah. I will say this, it's kind of hard for me to kind of get in the groove, like in a question test scenario. So, but usually I'll be able to kind of see it pretty quickly. I'll give you these formulas, like you won't need to remember, where did I put it?
we'll be pretty sure.
Yeah. And for the test, I will use the textbook questions again, right? And so I'll post the solutions to the odd ones like I've been doing, and you do the even ones. But ChatGPT is pretty good at doing them too. So if you're curious about the ones that you're submitting, then you can always check your work. Something like that, right? And yeah. Oh, well, because I made it do it. I know. That's how I made, because I was I spent so much of my life making solutions. It's crazy. And so I was like, aha, eureka, I'm gonna see how ChatGPT does. Well, I was very pleased with the results. But then it switched to a different algorithm or something. It was like, sorry, you've run out of your free tries. But then another student told me, oh, you just have to start a new chat. Didn't know that.
Yeah.
Now I know.
Mhm.
I'll get there.
It caps you out on.
Well, I was getting it to write the solutions in LaTeX. Yeah. I think it would just do the solutions. But then when it switched to the other engine, it was complete garbage. So, cuidado. Yes. No, my husband says that all the time. It kind of rubbed off on me. Yeah. Mhm. So, I will say this. As long as you are kind of consistent and you follow through with kind of what you started doing, then that's the best way to keep as many marks as possible, right? And so just kind of show me what you're going to do, and then just follow through with then follow through with that, and that'll keep you with the most amount of marks possible, right? Because it's hard for you to know, okay, am I on the right track or no? Right? And so, but I promise there'll be questions from the textbook just like before. The smirk emoji really took off, huh? Is it better than mine? Don't tell me. It is. I can tell. Okay. We ready for another one? Find the monthly payment for a car costing $15,000 if the loan is amortized over 5 years at an interest rate of 9%. This feels very true to life, doesn't it? It's implied that you borrowed the 15,000, right? Or you kind of finance it through the dealership or whatever, right? So the monthly payment for a car costing $15,000. If we, how can I draw this out? Oh, I promised to use the same setup that I've been using. What are we trying to solve for? We're trying to solve for M. And we're given first that N is 12, right? 12 payments per year, monthly payments. That one's sneaky because it's right at the beginning. 15,000 is going to be that principal amount that you borrowed. Right? And so P is 15,000. Amortized, I would guess it's to kill your debt, right? Amortized, right? You're chipping away at it, right? And so it just means that the term of this loan is 5 years. And so T is 5. At an interest rate of 9%, Emily, mostly. Although 9 can look a lot like 4. And that's all we need. And so I don't know if drawing the timeline is that helpful in this case.
Let's get right to it.
We can do
Skip the
this.
drawing.
We can do
Let's
this
get to it.
100%.
Hop 2. P, acting like just regular compound interest, has to 1 plus r over n to the n times t, has to be the same as m times 1 plus r over n to the n times t minus 1 over r over n. And we're trying to solve for m, but we have all the other components. $15,000 times 1 plus 0.09 divided by 12. Oh, I'm so curious. Is it a nice number? Sort of. 0.0075. It's pretty good. And is 12 for 5 years. So 60. Trying to solve for m, but for now we're just plugging in all our values. 0.09 divided by 12 to the power of 12 times 5, then minus 1. Don't forget that minus 1 divided by 0.09 divided by 12. I'll do another line to simplify this. 1.0075, I think it is. 0.09 divided by 12. I lost it. 0.09 divided by 12. Plus 1. Yeah. To the power of 60. Is m times 1.0075 to the power of 60 minus 1 divided by 0.0075. Clean that up. Yeah. All right. 1.0075 to the power of 60 is 1.565681027, which I'll store in A times 15,000. I get 23485.2154 is M I'll store that in B. A minus 1 divided by 0.0075. Right. Multiplication and division, as long as you've done this subtraction already, you're allowed to divide by 0.0075 to zip it up into one number. And so what this becomes is 75.4241363. Oh, square brackets. Did I do it wrong? I'm open to being wrong a lot of the time. Phew. Solving for M then, I get 23,485.2154 divided by 75.424133693. I should have written down where I stored that thing in B, I think. How does a monthly payment of $311.3753.284 sound for 5 years? Seems reasonable. Mm-hmm. So many coffees.
So many meals to win.
Mm-hmm. But that's boring. So you'd be making monthly payments of $311.38 to pay off your $15,000 loan over 5 years. Oops. Would pay off the loan of $15,000 over 5 years. How much have you actually paid? Right. So a follow-up question. How much will you have paid to borrow $15,000? You'll have paid, right? Every month you pay $311.38, and you do that for 60 months. It costs you $18,682.80 to borrow $15,000. That includes the $15,000 minus $15,000 or $3,682.80 in interest. All comes out in the wash. Nice. They actually didn't have any more examples in the textbook, but we do have the textbook problems we could do. The homework.
Let's go. Like, not like, let's do the homework. No, let's
I was gonna do my homework. And then you can do your homework. My homework is making these solutions. But I guess we could do these. No, let's do my homework, not your homework. homework off. So it's so funny, Steve in my office, because we all teach 4 to 6. And so we all leave for class and then we all come back at 6. And yeah, I got back late. He's like, what are you doing? We had a homework off. Where we do homework for a race, or as a race. So yeah, he actually wanted no part in a homework off. I know, right? Weird. So should I do it in the recording? The homework off?
No, they don't show up, they don't need-
Shots fired.
Come to class.
We'll use them as examples. How about that? I'll include them. This looks familiar, but it's a way better lottery. Sean has won a lottery paying him $10,000 per month for the next 20 years. Cha-ching. You'd rather have the whole amount in one lump sum today. If the current interest rate is 8.2%, how much money can you hope to get? And so in this case, right, we're trying to solve for P, right? And really for these types of problems, we're either going to solve for P or we're going to solve for M, and we're going to bounce between the two, right? And so, right, we've got some lump sum that's worth the same as these regular payments for 20 years. So how much money can he hope to get? Means I'm solving for P. We're given that M is 10,000 per month. So per month, that tells me that N is 12. And for the next 20 years, so T is 20. You'd rather have the whole amount in one lump sum today. The current interest rate, so R is 0.082. How much money can you hope to get? Okay. We've got our setup. P times 1 plus R over N to the power of N times T has to be equivalent to M times 1 plus R over N to the N times T, then minus 1 divided by R over N. One thing you could do if you wanted to is just once and for all, if you're solving for P, you can divide everything by 1 plus R over N to the N to the T, or N times T, okay? But it makes a really messy formula, right? And so I'm not gonna do that. I like to kind of have it simplified and then move things over as I need it. Same thing for M. You can multiply the other side by R over N and then divide by 1 plus R over N to the NT minus 1, right? And have it set up. You're allowed to do that. I will not. 1 plus 0.082 divided by 12. I fear that's not a very nice number. 0.082 divided by 12. It's not, it's terrible. So I abandon it. 12 times 20. M is 10,000. Now we're talking. What was the set for life? $1,000 per week?
Per week.
Mm,
Not bad,
not bad. I think I like this one better. 10,000. I guess we'd have to do the math to determine which one would be better. Something tells me we wouldn't get an interest rate of 8.2%. I guess I should check if you're doing your questions. I shouldn't be blabbing. Just be a pantomime. Distract you. If anyone wants the questions, I do have the printout here. If anyone wants a hard copy of the questions. to look at. Turns out I can't be quiet. It's my job. Luckily. Oh no, I didn't catch it. There's one that's linked to one of your guys' problems.
Always.
I need to do number 4. Oh, joke's on me. Fine. Wow. Here's a freebie. All right. I forgot to store it. Oops.
So should we just only go on that with this ones?
That's safe. I tend to just round, right? If it's followed by anything higher than 5 or higher, then I round up. And if it's followed by anything less, I round down. You guys want the printout of the questions instead? Or are you reading them?
Just about to get on that.
It's a little bit easier to read, I guess.
Like with six.
Everyone else has this. Nice.
Oh, no.
Oh, I see. So this one is after the fact. So you wanna do all of this and then take away that. And I think that's probably the only problem. Cause that would take you into it.
Number 6.
For number 6, since there's the down payment, what do you do?
Very interesting. How would a down payment work? You don't need to borrow that amount because it takes it off of the amount that you borrowed. Right? So you subtract it from your P because your P is the amount that you've borrowed. So I'll go look at 6. I see what's happening here. Trying to win this race. Well, I'll put up a good fight. Don't you worry. Is it 8? You guys are working with the down payment? Oh,
I guess 8 also.
2,000 down.
Yeah.
Mm. So that 2,000 is on top of the P that 300 per month is worth. Right? And so in this scenario, I would say it might be helpful to jot down, right? So here we are today and just kind of imagine it. So she first has to pay $2,000 down, and then she's gonna pay $300 for 5 years. And that's gonna be worth some P, right? But same way that a down payment works, this is the value of the car is the 2,000 plus the P. Right? And so, so you first find the P, same way that you have been doing, and then you add the 2,000, and that's how much the car is listed for. And I think that's the question. Jason wants to buy the same car, but wants to pay cash, right? And so that's the total value of the car in cash. Does that make sense? Does that help? Competing offers. Yeah, I think starting from there, they start introducing the down payment idea, but it's always the same. The down payment, right? The total value, this would be the value of the car or the value of the house or whatever it is, the overall thing that you're borrowing. But then this is the down payment, which you can take away from P, right? Or from that total value. And then the remainder is P. And so this is the down payment. Which is why you want to have a bigger down payment, because then your payments will be smaller. Unless your money can make more in interest somewhere else than the interest rate of your mortgage, for example. Hey, turns out I didn't need to do 4. I should have read the whole problem. I've been conned. Oh, well. A little extra.
Yeah, that's not fun.
You could just treat it as 6% compounded annually. So there's no payments. Which will the price be? Yeah, I would read this as 6% compounded. So in that case, N would be 1. Because it's once per year. Oh, these would be 2 separate scenarios. So the rate stays at 6% per year for the next 5 years. What's the accumulated amount? So what's the price? So that 15,000 is just gonna sit there and grow. But then, this one is different. How much must you save? At the end of each month, so the price of the car, 15,000, is gonna grow for 5 years. And so it's this one, do you want this simpler? You want 1 plus R over M times T. This one requires payments here. And so what it's asking is, if R is 0.6 and 15,000 plus 6, that amount. Then you want to force this A to be this amount. Is that a question pause? I feel like there's like a hesitant. Let's see. So. To solve for now. So here your choice needs to be. But. Oh, I'm gonna get 8. Because this is 60. Is that one? Yeah.
Oh. That's right. Thank you.
I was like, I want to finish it and scan it right now and just go. I didn't do any of it. I did the first question.
Siempre rompiendo mi corazón. Chao, amigo.
Ciao.
Mi querida, chao.
so far.
One had a place.
What doesn't this
Well,
do?
she's getting a car, and she paid $2,000
It's
for that.
$40,000 car.
No.
So, because everything was,
I want that divided with that.
I was texting them that, we're getting your car.
That's what I thought.
A $40,000 car is a lot more here.
So whichever number has.
This is
like,
a new
the
car.
And that's what you.
correct? Okay, so then you wanna like kind of.
We actually don't know if it's a new
Yeah.
car.
Get that off by.
And then after we get that number, then we subtract the.
Like something's gonna go wrong the next week.
So then this, yeah, so then this gets.
There's not a lot of work.
Oh,
Like,
like,
that's it.
oh, okay.
Cause she's gonna.
Like, I'm just saying, like, there's
It's
not a
only
lot of work.
14,000.
I mean, look, my question is on the six months.
With those payments,
You also have.
but then she's also.
Okay.
Nice.
You don't get
So,
to-
so close, yeah, I'm like.
You always have to do a second time.
That's great.
I guess I should stop this recording. Wow, how boring.
You subtract it and then you multiply it.